Okay, welcome to day 2 of Radicals, Unit 6. Today we're going to be doing simplifying radicals, so let's start with the notation. The first radical sign that you've seen is square root. It looks like this. Basically what we have is a number sitting on the index right here, and that's a 2. That's imaginary. Well, not imaginary, but you know what I mean. It's sitting on the ledge. Also, there's an exponent of a 1. So when we write the square root in exponential form, we write it as x to the 1/2. Okay? The next one we have cube root. Here we have 3 on the index. Of course, there is a 1 exponent there. So we would write it as 1 to the 3rd. I'm sorry, x to the 1/3. Fourth root, you guessed it. That 4 goes in the denominator for the exponent, and it's written as x to the 1/4. And then the fifth root, here we have the 5 on the index, so we write it as x to the 1/5, and so on and so forth. So as we move down to part 2, we have square rooting perfect squares. Now, for the first one, for letter A, we have the square root of 36. We should know that the square root of 36 is 6. Why don't you try B on your own? You can use a calculator. You should have gotten 11. Perfect. Now let's look at C. This one looks a little different. It doesn't have a square root here, but it does have 25 to the 1/2 power. What did we learn at the top of the screen here? What does it mean when something is to the 1/2 power? It just means that it's a square root. So we can rewrite this as 3 times the square root of 25. We know what the square root of 25 is. You could also check it in your calculator, but the square root of 25 is 5. So we end up getting 3 times 5, which is 15. Go ahead and try D on your own. You should have gotten 28 for letter D, because we know the square root of 49 is 7, and when we multiply that by 4, we get 28. Let's look at letter E. This one looks difficult, but it's not. There's just a half in front being multiplied to the square root of 256. Now, the square root of 256 is a large number. All you have to do is plug it in your calculator. You should get the number 16. So what I'm going to do is rewrite what I have in the front, which is the 1/2, and times it to 16. What is 1/2 of 16? Perfect. You get the number 8. Okay, so that's square rooting perfect squares. Just some practice with that. Let's move on to section 3, which is square rooting not so perfect squares. So here's a little hint at the top. It says look for groups of 2 factors to bring out of the radical. All right, so here's a little example right here. Can you remember what to do with the square root of 20? So for example, we gave you a hint. We told you the square root of 20 is the same as the square root of 4 times the square root of 5. Why did we choose those 2 numbers instead of the square root of perhaps 2 and the square root of 10? Because the square root of 4 is a perfect square, and it's equal to 2. So when we take the square root of 4 and the square root of 5, we're able to rewrite the square root of 4 as 2 and can rewrite our answer as 2 square root of 5. Isn't that simple? Perfect. So now let's try these. And remember, you want to find the perfect square to come out of the square root, and the rest stays under the square root. So in our first example, A, we have 75 to the 1/2 power. Remember what we learned in section 1, that to the 1/2 power is the same as writing the square root of 75. Now, of course, this is not a perfect square, so we need to think of a number that is a perfect square that goes into 75. The one that I could think of is the square root of 25 times the square root of 3. Now also, when you remultiply these back together, the square root of 25 and the square root of 3, you should get the square root of 75. When you take the square root of 25, you get the number 5. And can the square root of 3 be broken down? The answer to that is no. So we write our answer as 5 square root of 3. Go ahead and try 18 on your own. Or I'm sorry, letter B on your own. as you're working, you can see that I'm showing you my work as well. You should have gotten 3 square root of 2. What I decided was 2 of the factors of 18 are 9 and 2. 9 is a perfect square, so when I take the square root of 9, I get 3. And the square root of 2 cannot be broken down, so it just stays there. And then we put it together to get our final answer as 3 square root of 2. What about letter C? Again, this is 600 to the 1/2 power. So how would I rewrite this? We write it as the square root of 600. I want to find 2 numbers that multiply together that will give me 600, where one of them is a perfect square. One of the numbers is the square root of 100. The other number is the square root of 6. Why did I choose the square root of 100? Because that's a perfect square that goes into 600 and can be broken down perfectly. So what is the square root of 100? We get 10. Can the square root of 6 be broken down by a perfect square? No. The only thing I could think of is the square root of 3 and the square root of 2 being multiplied together, or square root of 1 times the square root of 6, which doesn't help us. So our final answer should be 10 square root of 6. And then try the last one on your own. You may pause this video and then press replay to see my answer. All right, so when you press play back up there, you should have chosen the square root of 49 and the square root of 2. We know that the square root of 49 is equal to 7. And the square root of 2 obviously cannot be broken down, so we write our answer as 7 square root of 2. Now, just as a little tip that maybe your teachers won't tell you, but I will, is that if you put in the calculator the square root of 98, you're going to get a number, okay? If you also put in 7 square root of 2 in the calculator and push enter, you should have decimals that look exactly the same. So that's a great way to check your work. Moving right along, let's try E, okay? The perfect square that I can think of is the square root of 144 times the square root of 2. Square root of 144 is 12. Square root of 2 cannot be broken down, so I write my answer as 12 square root of 2. Now, F looks a little different than what we've seen because we have a radical with a fraction underneath. Now, there is a hint, and we wrote to you guys saying that you can put the square root of 3 over the square root of 4. It's the same thing. So this is the same thing as this, okay? Now, why did we give you the hint and break it up like that? Because we know that the square root of 3 cannot be broken down, but the square root of 4 is the same as the number 2. So our final answer would be the square root of 3 over 2. Now go ahead and try G on your own. If you want to pause the video and then check your answer on mine, that would be a good idea. Okay, so how we get the answer is the square root. Sorry, a little technical difficulties here. Moving the board around. All right. 8 over 25 to the 1/2 power is the same as writing the square root of 8 over 25, or just like we saw in this hint up here, it's the same as writing the square root of 8 over the square root of 25. Now look in that denominator. We can't have a radical in the denominator. We're going to want to break that down. Now the reason I'm starting there is because I know that that's a perfect square. All right, the square root of 25 is 5. You also need to make sure that you look at the square root of 8, because a perfect square does go into the square root of 8. So I'm just going to write down here, and I'm going to have the square root of 8 over here. So how do I break this down? I'm thinking of a number that's a perfect square that goes into 8. I'm thinking of the square root of 4 times the square root of 2. What is the square root of 4? That's the number 2. Square root of 2 cannot be broken down, so we write the square root of 8 as 2 square root of 2. So our final answer for letter G should look like this. 2 square root of 2 over 5. And I'm sorry that it's right in the little corner right there, but as a math teacher, we're going to write wherever we can. All right, moving along to section 4. Hope that you guys got that right when you worked on it on your own. Section 4 is cube rooting perfect cubes, okay? So the directions state, write the equivalent to each of these radical terms, okay? So now just like when we did square roots, we were thinking of two numbers that multiply to that number under the square root. The index tells me how many numbers I need to multiply to get that number. So you want to think to yourself, okay, 1 times 1 times 1 is equal to 1, okay? We can also think to ourselves, well, 2 times 2 times 2, that's going to give you the number 8. These numbers on the sides are numbers that you should have seen already in previous units, but are very good to memorize because you'll see them very often. 3 times 3 times 3 is 27, 4 times 4 times 4 is 64, and 5 times 5 times 5 is 125. You will possibly have numbers that are larger than that, but those should look very familiar to you. So when we look at A right here, we have the cube root of 8, okay? Again, this can also be done in the calculator by pushing math 4, and that should pop up the cube root, and it should look like this in the calculator, okay? Then all you need to do is put the number 8 in and enter, and you should get the answer 2. Excellent. Now this one looks a little tricky because guess what? There's a negative under the square root. And what we've learned is that when there's a negative under the square root, that it's an imaginary number. But in this case, it's a cube root. Okay, so we're thinking of 3 numbers that are the same when multiplied together that would give me negative 27. Okay, so obviously a positive times a positive times a positive would not give me this negative right here. So what do you think? It's got to be a negative. What gives me the number 27? Right over here, one of those that I told you to memorize. 3 times 3 times 3. So the cube root of negative 27 is 3. Wonderful job. Why don't you go ahead and try to do letter C on your own. Pause the video, and I'm going to give instruction after so you can check your work. Okay, so now we've just picked up after you paused. I'm going to look at this problem, and I want to rewrite it using the cube root because I don't like to look at exponents. So here I have 3 times the cube root of 125. What is the cube root of 125? Well, we can plug this into the calculator, all right? Just like I showed you over here, you hit math 4, the cube root should pop up, and you plug in 125. It should give you the number 5. Or, if you listened, you memorized these 5 numbers over here to realize that the cube root of 125 is 5. We end up multiplying the 3 that was on the outside. Do not forget to bring that down. 3 times 5 is 15. Excellent job. All right, go ahead and try D. Pause the video and then check your work with my work. All right, and we're back checking our work for letter D. Here I have 4 times the cube root of 64. Well, what is the cube root of 64? Again, we can look at our trusty notes over here with this group of numbers. Cube root of 64 should be the number 4. So 4 times 4 equals 16. Excellent job. Now let's try letter E. Here we have 2 times the cube root of 216. Go ahead and plug that in the calculator, and we're going to get the number 6. What is 2 times 6? 12. Excellent job. Cube rooting not so perfect cubes. All right, so this is the part where it gets a little tricky because you can't just put these numbers right into the calculator. So let's look at letter A. The directions state, simplify these, but remember, perfect cubes come out of the radical sign and the rest stay in. All right, so let's go ahead and look at letter A, and I'm just going to rewrite this as the cube root of 16. So just as we did this with square roots, where we broke it up to pull out the perfect squares, here we want to pull out the perfect cubes. All right, so I want you to think back to that list of numbers that's up here. All right, and I'm just going to give it to you on the side over here so that you have it. And I want you to think of which of these numbers goes into 16. All right, so when I look over here, 1 doesn't really help us. So you actually really don't even need that number, but you should know that 1, the cube root of 1 is 1, and 1 to the third is 1. We love that number 1. When I'm looking over here, I see that 8 goes into 16. So I'm going to break this up, and I'm just going to keep it like this. The cubed root of 8 times the cubed root of 2. What is the cube root of 8? You guys are going to tell me that's 2. Can I break down the cube root of 2? The answer of that is no. So I'm going to rewrite this as 2 times the cubed root of 2. And that is how we simplify not so perfect cubes. So let's go ahead and look to letter B. So now we want to look to the side, and we want to see which numbers go into 243. So now go ahead and try B through D on your own. Make sure you pause the video, and then when you hit play again, you will see all the answers pop up on the screen. All right, so now you just press play. You can see that the answers for B through D are there. Make sure you check your work. If you have any questions, bring them to class tomorrow, and we can discuss them to make sure that you understand how we got those answers. So now we're going to look over here to section 6 when it says, when variables are involved, we need to make sure to look for groups of numbers and variables that match the root. So the directions state, write the equivalent to each of these radical terms. Now looking at the first one, we should know right off the bat that the square root of 121 is 11. Okay? I want you to also remember that the index here is a 2. All right, so we're taking the square root. When we take the square root of x squared, that's like saying x times x. So what's the square root of x times x? It's just x. Same thing with y squared is y times y. Take the square root and you end up getting 11xy. And that would be your answer. Let's try a cubed root one together, letter B. What's the cubed root? You can think of it like this. The cubed root of 27 times the cube root of x to the third times the cube root of y to the 6th. So you can look at them separately and then just put your answers all together. The cubed root of 27, you get 3. All right, when we do the cubed root of x to the third, I want you to think of x to the third as x times x times x. Here we have a group of 3 x's. That would satisfy this requirement here of the index of 3. So the cubed root of x to the third is just x, and then y to the 6th in the cube root, you get y squared. Now you might be asking yourself, well, how did you get y squared? Well, think about it. We have 6 y's here, and they're being multiplied together. That's y to the 6th. We're looking for groups of 3 y's. Here is one group. Here's another group. So I count this as y times y, which gives me y squared outside of the radical. Go ahead and try C and D on your own. All right, so when you click back on play, you see the answers to C and D. I tried to show you some work so you can check your work there and see the final answers. Make sure that you got the same thing that I got. All right, now let's go to the next page. We're in the home stretch, so hang in there. All right, so we have ones that are not so pretty. Let's look at letter E. So what we want to do is we have the square root of 50x to the third. So again, think about it like this. This is 2 times the square root of 50. All right, I'm going to pull out the numbers and I'm going to pull out the exponents into separate radicals. That way we can look at it separately. So again, the square root of 50 is breaking down a not so perfect square. So what you want to think of is, well, what perfect square does go into 50? I think of the square root of 25 and the square root of 2. Okay, so what I end up getting here is 5. When I take the square root of 25, I cannot do anything with the square root of 2. All right, and I'm kind of just leaving the square root of x to the third till the end. Let's look here. 2 times 5 is 10. Okay, and I also have the square root of 2 here. Now you can see how I left a little room to see what's going to happen with the square root of x to the third. Now remember, we're doing square roots, so we're looking for groups of 2. Here we have 3 x's multiplied together, which is the same as x to the third, and here's one group of 2. So what we like to teach in class is we like to say this. These 2 x's, here and here, these guys are in jail, all right? And they need each other to break out of jail. And that jail, you guessed it, is that radical sign. So what we do is we say they both come out, but what happens is one guy gets shot, but the other one gets away. And he gets away to come outside of jail, okay? But now look at this little guy over here. He has no partner, so he has to stay in jail until he gets another partner. And that's how we get our answer of 10x times the square root of 2x. Go ahead and try F, G, and H on your own. Once you hit pause and then play again, you'll see the answers pop up. All right, so to show you guys the work, here's the answers for F, G, and H. Go ahead and check your work. I know G looks a little complicated, but I wanted to show you guys how I got some of the answers there. Try to make sense of it. Any questions, bring them to class and we can answer them there. And now for the finale of the lesson. So here we're talking about higher roots. So here we have a 4th root, here we have a 4th root for B, and here we have a 5th root for C. So what we're going to do is we're going to look for groups of numbers or variables that match the root. Now I know my colleagues show this where we break down 81 into we do the prime factorization. So what we're going to do is square root of 81, we're breaking down the number 81, 9 times 9. 9 and 9 get broken down to 3 and 3, and again 3 and 3. And I circle them to show that those are prime numbers. Now remember, when we're talking about a 4th root right here, we're talking about 4 numbers that are the same, that will multiply to give us that number on the inside, that 81. Well, look here. We have 3 times 3 times 3 times 3. If you check that in your calculator, you'll notice that these numbers, or 3 to the 4th, is equal to 81. So think about when we talked about people under the square root coming out of jail with partners. Here you need 4 partners to come out of jail. So here are the 4 partners. But guess what? Out of these 4 partners, 3 of them get shot and only 1 gets out of that jail. So what we have is 3 in our answer so far. And I'm just going to go ahead and put our answer down here. I like to kind of give myself a spot to put my answer. Look at x to the 4th. Here I have 4 x's. I need a group of 4. Well, here are my 4. And remember, 3 of them get shot. They try to get out of jail, don't escape. 1 does, and that becomes my x in my answer. And then, of course, y to the 8th is just 8 y's being multiplied together. And we're looking for groups of 4. So there's one group of 4, there's another group of 4, so I write that as y squared. Because remember, these 3 get canceled out and 1 comes out. But remember, we also have a group over here where 3 don't come out of jail and it comes out. So we end up getting y times y, which is that y squared. So go ahead and try B and C on your own, and you have concluded day 2 of Unit 6, Simplifying Radicals. Okay, at this point, you should see your answers for B and C. I know these ones are a lot to look at, but check your work. Make sure you got the same answers that we got. And if you have any questions, bring them to your teacher. You guys did a great job listening. Hope you enjoyed the video. We'll see you on day 3.